In this video, I'm going to talk about the transformation of trig functions. In the previous videos, I've talked about how to graph sine, cosine, and tangent functions, so it's time for the transformation part. So first of all, let's have a look at the vertical dilations. So a vertical dilation is how a graph changes on its y value. For example, a vertical dilation of scale factor 3 of the function x would be y equals to 3 times function x. In trig function, however, if the function y equals to sine x has a vertical dilation of 3, which makes the function to y equals to 3 times sine x, in this case, the amplitude of the graph will change from 1 to 2. So the graph will turn out to be like this. The same thing also works on the cos function. So the function y equals to k times sine x, or k times cos x, they have an amplitude of k. And if k is equals to -1, the graph is reflected from the x-axis. Okay, now you know how vertical dilations work in trig functions. Let's take a look at horizontal dilations now. So a horizontal dilation of y equals to function x would be y equals to function a times x. In this case, the scale factor is not a, but 1 over a. Okay, the same example here, y equals to sine x. If y equals to sine x became y equals to sine 2x, in this case, the graph will not stretch but compress. A new graph will look like this. As you can see, the period of the graph came from 2 pi to pi. So we can say that if y equals to sine a times x or cos a times x, and we have 10 this time because 10 has only period but not amplitude. The period will become 2 pi over a, and in the case of 10, it will become pi over a. And if a equals to -1, the graph will reflect on the y-axis. Okay, that's it for the first part of the transformation of trig functions. In the next video, I'll talk about the translations of trig functions. So if you don't want to miss out the video, don't forget to subscribe, and I'll see you in the next one.